For decades, science fiction has sold us a very specific idea of a wormhole, a massive, swirling cosmic subway that ships can fly through to cross the galaxy. The actual science of wormholes rapidly shrinks away from deep space and down into the microscopic quantum code that holds our reality together. In classical physics, an Einstein-Rosen bridge is imagined as a spatial shortcut. Think of it like digging a tunnel straight through the center of a mountain to get to the other side, rather than walking millions of miles all the way around it. But there is a fatal flaw in the math of general relativity. If a macroscopic wormhole actually forms in space, its own massive gravity causes it to pinch off and collapse. The tunnel crushes in on itself faster than a beam of light could ever cross it. As theoretical physicist Kip Thorne demonstrated, propping those tunnel walls open would require massive amounts of a hypothetical substance called negative energy.
It is a requirement that makes macroscopic, traversable wormholes a physical impossibility with our current understanding of the universe. These space travel portals are mathematical dead ends. Yet the world's leading physicists remain obsessed with them because they have stopped looking at the scale of stars and galaxies and started looking at the microscopic fabric of space itself. In 1935, Albert Einstein co-authored two famous papers. One described the geometry of wormholes, the ER bridge. The other outlined quantum entanglement, or EPR, where two distant particles become perfectly linked. For nearly 80 years, science treated these as completely separate phenomena. Then, theoretical physicists Leonard Susskind and Juan Maldacena proposed a connection. Their equation, known as ER equals EPR, suggests that Einstein's two papers were actually describing the exact same physical mechanism, just viewed from different mathematical perspectives. Traditionally, quantum entanglement is viewed as a spooky connection. Two isolated particles sit separated by a vast, empty void, yet they change their physical states simultaneously. There is no visible force connecting them to explain the reaction. ER equals EPR resolves this mystery. These particles are physically stitched together by a microscopic, non-traversable wormhole. These microscopic quantum wormhole threads weave the entire fabric of the universe. Because we cannot build a giant wormhole in deep space, physicists decided to synthesize one. In 2022, researchers turned to Google's Sycamore quantum computer to test this entanglement theory. They used the SYK model, a specific quantum framework capable of mimicking gravitational properties. By programming this into the processor, they recreated the precise mathematical conditions of a wormhole. To test it, they needed a trigger. The team injected a simulated pulse of negative energy into the system, applying the exact mathematical force required to hold a theoretical spacetime bridge open. Instantly, a qubit, a single unit of quantum information, teleported from one side of the quantum processor to the other. When you translate the data of that teleportation into the language of gravity, the dynamics match perfectly. The quantum information literally passed through a traversable wormhole. Human beings have now successfully observed traversable wormhole dynamics in a laboratory setting. This success in the lab raises a major question about the actual cosmos. If macroscopic, traversable wormholes exist in deep space, we need a way to differentiate them from standard black holes. Physicists recently developed the MMP model, which maps out the exact physical geometry of a horizonless, traversable wormhole. This graph shows the effective scalar potential. Notice the structure of the curves. An MMP wormhole features a double barrier throat, acting as a resonant cavity. Waves become trapped in the valley between the peaks, bouncing back and forth, slowly leaking out as gravitational echoes. Observatories like LIGO now have a specific, measurable signature to look for. By listening for this ringing bell effect in spacetime, we can actively hunt for these exotic structures in the real universe. The most recent research pushes the Einstein-Rosen bridge even further. Physicists are now exploring the idea that these bridges are mirrors across time. This addresses the black hole information paradox first identified by Stephen Hawking. For decades, physics has wrestled with the problem that any information falling into a black hole appears to be permanently destroyed, breaking the core rules of quantum mechanics. A temporal bridge solves this paradox. The information is never destroyed. Instead, it crosses the bridge and continues evolving along a reversed mirror arrow of time. A moment of wonder. Expand this concept to the largest scale possible, and it provides a new model for the birth of our universe. Our entire cosmos might be the interior of a black hole, birthed from a parent universe that collapsed, bounced back, and expanded outward. This model reimagines the Big Bang as a temporal gateway, a continuation from a preceding cosmic era. The math shows that the entire fabric of reality, and our very existence within it, is already woven together by billions of quantum wormholes.